Hey everybody, how are you guys doing? I'm Eric Airlock, and this is another talk on philosophy, logic, and a bit on Peano. Just a little bit. Peano and set theory. So, another powerful and useful addition to formal logic that serves as a visual and mathematical bridge between the work we have been covering of Boole, Carroll, and Venn in these My Logic lectures, and the works to follow of Russell and Frege, Russell, and Wittgenstein is set theory, which was founded by the Italian logician Giuseppe Peano, who lived from 1858 to 1932. And this was itself then extended particularly by the work of the German logician Frege, who lived from 1848 to 1925. And he was actually about a decade younger than Peano, but was using his work and others. So we are going to cover Frege, Russell, early Wittgenstein, and the basics of formal proofs in the talks to come. But before that, we're going to consider here for a shorter talk, because I confessedly cannot incorporate a whole lot of Peano into my informal logic, but he does need to be these talks. And I am not the expert on him, but he should be mentioned and is an important precursor to Frege. And I know more about Frege because I studied a bit with Sluga, and he is an expert on Frege and Wittgenstein, and I am thankful for his work. So we are going to cover Peano a bit because he's a precursor to Frege, which is why I'm fitting him in here. So, Peano, who was unfortunately never stationed, as far as I know, at Fort Isimo, because I don't think there is a place, and that's a bad music theory joke, in theory. But Peano was born rather on a farm in Spinetta of northern Italy, and then taught at the University of Turin, so if Peano had grown large enough, he could have been a Gran Torino. He tried to popularize a universal utilitarian, not Unitarian, that would be somewhat different, a universal utilitarian language he created out of simplified Latin without inflections called Latino sine flexione, if I'm getting that at all right, in Latin or Italians, and gave a lecture about it in 1908 that explained the language as the lecture turned from Italian into, word by word, his simplified Latin with each step of the talk as he explained it, which is quite brilliant. He wanted to create a simplified Latin and then hoped that could be a language of Europe. That did not come to pass. He wrote a textbook on calculus, created a space-filling curve, which you can see in my notes and online, which does prefigure the modern fractal and the work of Mandelbrot. And he came along working for IBM such that he could see on screens the mathematical patterns like the space-filling curve of Peano, who filled that out on paper. Peano also at one point was so frustrated with publishing delays that he bought his own printing press to print his own works and distribute them. At the Second International Congress of Mathematics in 1900, Peano met Bertrand Russell, who left the Congress right after. He left in the middle of it, apparently, and went home to London to immediately begin work on Peano's logical notation, because Bertrand Russell wanted to create a logic of thought much like Boole, and wanted to make it for more philosophy and for general human thought, and which arguably logic is supposed to be anyway, but make this mathematical logic a bit more for common thought and argument, which is odd because now we go full circle through that. From the Aristotle through the Boole and through Peano back to practical, somewhat thinking with Russell, and we will leave more of him until later. So Russell did, though, we can say, completed more than 300 pages of his Principles of Mathematics before he discovered Frege's work, which he combined with Aristotle, Leibniz, Kant, Boole, Carroll, and Peano to form the basis of what became logical positivism, which is the ancestor and quite close to analytic philosophy, and the early work of Wittgenstein and truth tables, which is much of the basis of the formal logic we still teach people in an introductory logic class. And I teach, even though I like this from a more historical and, historical and psychological angle, as Sluga says in his work. So unfortunately, the next year, in 1901, Russell discovered a paradox in Frege's work, inspired by a logical problem about a barber by Carroll, which we will discuss next with Russell. Actually, we will discuss after Frege next, quite seriously. In basic set theory, union is a set of A and B together. Intersection is all that is both A and B, the center slice of the Venn diagram with two circles overlapping. Set difference between A and B is whatever A isn't also B, like an exclusive OR but that works one way, also called the complement of B and A. Symmetric difference are the parts of A and B they do not share. And the Cartesian product, as if Descartes is a drug kingpin. I know a guy, he's a bit dualistic. You'd have to teach people about hard dualism before they learn about it, unfortunately, on the street. That the Cartesian product for Peano is all possible ordered pairs of sets A and B. Now, that last one is particularly historically interesting, because if you look at the ordered out sets of all possibilities, they resemble very much and are a precursor to, certainly, Wittgenstein's truth table method of T's and F's, because he is placing out as a Cartesian product, if you will, a la Peano, in T's and F's, how T's and F's work in basic truth table logic. So Peano's arithmetical system assumes 5 postulates, and I have to be a bit of a critic here. I am not the mathematician, but I am the Wittgensteinian, so I am going to say a thing or two here about this, even though I am certain this works mathematically in wondrous ways. I would not doubt it. Peano's arithmetical system assumes 5 things. 1, first and foremost, 0 is a number. Now, that is a novel way of starting a system, and Russell thought, hey, I can found a bunch on this, and let's start to work with this. Now, the interesting thing, though, is this is perhaps quite elegant and quite fitting a model. But for many cultures, just have to say, 0 wasn't a number, or isn't, or what have you. So, is this all of how math truly is, or is this a structure of representation that forms along with math, but then isn't exactly it, because for many people, they didn't practice. Or, in fact, did those people simply not fully understand mathematics and understand that 0 was a number at the time? Well, of course, that is a little problematic. But let's just say Peano is doing an amazing job of modeling arithmetic and how it functions in his way that then Russell finds inspiring, which is certainly the case. So 0 is a number. You start with that, which, again, the Mayans may have, but not the Greeks. So what? 2... anything that follows a number, its successor, is itself a number. So anything that follows the first, 0, is a number. I guess if zebras follow 0, they are numbers. 3, no 2 numbers have the same successor, or something that follows something similar in type that would keep it from being circular and push the line outward. 4, 0 doesn't follow any number, is not a successor. That keeps anything from happening before 0. Unfortunately, that's a bit of the negative number problem. And if there are negative numbers, imaginary or not, with their squares and roots, that again is a bit of a problem. 5, if 0 has property p and every number with p has a successor that follows it, that also has p, then all numbers have p. That gives you mathematical regularity in a whole lot of ways. Unfortunately for Peano, historically, Gödel's incompleteness theorems famously threw a large wrench into his plans for a complete and unified set that grounds all of mathematics coherently together. I am not the Russellian, I am more the Wittgensteinian, and latter at that. But Logic Comics is a graphic novel I highly recommend, which talks about the life of Bertrand Russell for the Carroll Society and the Alice in Wonderland folks who are interested. It does mention Russell and a bit of his, only a page or two, and just an allusion or two, to Lewis Carroll, and mention Russell was compared to the Mad Hatter in his time. I'll say more of that with Russell. But in there, it pictures in there, and have to mention with Peano here at the end, that after hearing Gödel's theorems, Peano is pictured in Logic Comics, and supposedly this is drawn from accounts, is that he is pacing in circles and circles, chain-smoking cigarettes, puffing away, saying, it's impossible, over and over to himself as he circles around and around smoking cigarettes, trying to outthink Gödel, because essentially what Gödel said, without getting into any mathematics of it, is that there isn't a complete set that simply is mathematics and it all adds up into one simple unified system. So it is, in a certain sense, modeling and operative ways of things, but they may not all add up into a model. A la Wittgenstein, the way that Wittgenstein phrases this idea, whether or not it comes before or after or is inspired by Gödel or not, and it is interwoven with all of that, is we have a loose toolbox. That you don't have a tool, it's not a Swiss Army knife of all knives that makes it all add up as a math that's perfect. Math, and you could say thought and life for Wittgenstein in extension, and any logic or behavior is itself a loose toolbox of diverse elements and not something that underlyingly has a structure necessarily. At least we can't arrive at it in certain ways. So it may, but we just can't really prove it at all, is basically what Gödel showed, and then Peano tried to outthink, and as it is presented in Logic comics, unfortunately, he seems quite the guy, but unfortunately he is presented a little poorly in his end in Logic comics, which is him pacing around and around endlessly in a circle trying to close the loop with himself, a cigarette or many, and thinking, and he doesn't seem to manage to do it, which unfortunately makes him a bit of a comic character in that comic. It is impossible that math is not a complete set. I have to say here again, with Wittgenstein, it feels to us like mathematics should fit. And it feels again and again like math fits. But try as we might with Peano, it may not all feel like it fits, whether or not we take the dance steps at Gödel or not, via symbolic mathematics and formal logic. That said, that is the short talk on Peano. I'm going to follow this with a longer talk on Frege. Again, I like the work of Sluga. I am thankful for learning with him. The classes I took many, many years ago as an undergrad. And with all of that, I am going to get into Frege and then Russell and then my favorite of the modern philosophers, and we'll slowly talk that out in his thought experiments, Wittgenstein. And that, actually, the walking through Frege to Russell through to later Wittgenstein is already going to resemble a lot we've talked about, and I've been mentioning with Lewis Carroll and here with Peano in this talk and with Boole, is that ancient logic was not necessarily an airtight system, but it was how do we debate as airtight and as certainly as possible from A to B to C. But after Islamic algebra and a lot of mechanics and technology from China, the Islamic world, the whole world over, getting to the Americas, and then we have new thinkers and new cultures that are trying to make logic algebraic as a kind of formal mathematics, and that is going to work and not work. That is the overflight here of what's going on, and that is why Peano's pacing in a circle, and I'm going to take us onwards to later Wittgenstein, by way of a decent amount about Frege and Russell first. So much happiness, much love to you and yours, and I will see ya, if I ever do see ya.